Samsung, Jovino, okay. I record. Thank you so much for record. Let's move on to the whiteboard. Do you see the whiteboard? Do you see or no? Yes or no? Yes, not yet. Okay, sorry. Let me try. Not yet. Not yet. Let me see. Now? Now? Yes, good. Okay, guys, exponential function. This is a new function you never see before in your life. Exponential. Okay. Exponential is like a transcendental function because there are a bunch of functions is called transcendental because it's transient to the polynomial, quadratic function, rational function. It's a new one. It's a new one. This is just a name. Transcendental. Exponential is important. So let me go to the definition. Definition of the exponential function. Bueno, es the function que look like that. A to the x. And who is A? A is the base. This number is called the base. And the base is, be careful, is a real number, but not all real number. So we have some restrictions. So A, get the base, is real number. But no negative. O sea, A is non-negative. Always the base is positive. For example, you see in one example, -2 raised to the x power. This is not exponential function. And also, A is no 0 and no 1. Because 0 and 1 are totally trivial. Example, because 0 raised to the any number is 0 and 1 to the any number is 1. So it's a stupid function, no? One fantastic example is, we discussing today 2 examples, or maybe more. Example 1 we discussing today is the function f of x equal to the x power, no? Like that. You are familiar with the quadratic function que es x to the second power. It's the classical parabola that everyone knows very well in college algebra. But in this case, different. Look, the order of the number is different. 2x exponent, and the base, que es x, is a variable. In this case, no. In this case, the base is constant, is 2, and the variable is located in the exponent. And this change completely the behavior. Completely the behavior. Okay? For example, if the base, que say, is a number greater than 1, like this example, no? 2, 3, 4, 5, 1.5, because maybe it's possible decimal, fraction, okay, but greater than 1 is increasing. Increasing exponential. And some book called exponential growth. Like a growth. Because it's increasing. And when the A, the base, is no greater than 1, it's in between 0 and 1. Remember, 0 and 1 are illegal, guys. Because it's trivial. And no negative, no. Exponential negative is not exponential. So you try to create one exponential with the base negative, no, it's impossible. You are doing wrong. By definition, it's wrong. So it's decreasing. You see in detail exponential. So the technical name of this kind of exponential, sometimes called decay. Decay is synonymous to decreasing, and growth is synonymous to increase exponential. Guy, but you have no idea how the exponential function increasing too fast. It's not the most function increasing too fast, but increasing too fast. So you compare, for example, the parabola, is x squared, versus exponential, 2 to the x, with the same number, 2, because see, I change the number, the cubic function versus 3 to the x, okay? This is cubic function, and this is also the family of the exponential. The only difference is the base in this case is 2, and the base in this case is 3. It's obvious when the base is bigger, numbers are 3 increasing faster than 2. But this and this increasing super faster, the exponential increasing super faster than polynomial function, the family of the polynomial. It doesn't matter if the exponent is, for example, 2000 versus 2 to the x, this win is increasing faster than this. Okay? To illustrate this idea, I create some puzzle. Funny. This is the funny part. I would like you participate in this idea. The student can get the answer of this puzzle. You have 10 points extra in the test number 4, no? I want to explain the puzzle, okay, right now, and pay attention. Try to figure it out, the answer for this puzzle. The student have only one opportunity to get to answer. You fail, you for the chat, you type no using the microphone because I don't know exactly what they got. You type it. The answer is 45, professor. Wrong. So I copy your name here. Maria. Wrong. Okay. Another guy. Got it. See, you got it. 10 extra point for the test form. Okay, but only one possibility. And you guess, no, 30, 40, 45, 55. No. Okay. Okay, let me explain the puzzle. The puzzle is about the coronavirus. Do you hear that the propagation for the coronavirus is exponential function? Coronavirus. Okay, let me try to find one coronavirus. Coronavirus. I have here the image for the coronavirus. Okay, coronavirus here. Boom, coronavirus. And this coronavirus contaminate the student in Miami-Dade College, no? Wow. Because the students have no protection. I don't know exactly what happened. Something is wrong. Entonces this we have suppose Miami-Dade College. Suppose Miami-Dade College. Another image of the one building of the college. Miami-Dade College. Okay, this is hypothetical college, not Miami-Dade. This is one college. Okay. And inside the college, you see a student, no? In the garden, the student. Wow, what the hell happened? Wow. Okay, let me rotate the image of the college. This is one hypothetical college, not Miami-Dade College. It's a college. Okay? And this virus infect one student. Now means time 0. Time 0. So time t equals 0 is now. And suppose that the rate of propagation, suppose hypothetical, is contaminate 2 students. 1 student contaminate 2 students. Maybe si you contaminate 3 students or 10 students, I suppose it's faster, no? But to simplification the thing, I suppose que en t equal 1 day, inside the college are infected 2 students. Entonces, my question is, how many students contaminate this in 2 days? How many? How many?
4.
4 students. Okay. Little by little, you understand exponential function. You understand little by little, you understand. Nice. 4 students. 4 students, 2 students, 1 student. What about, Launa? What about how many students is infected in 3 days? Okay, how many students is infected in 3 days?
8.
8. Very well. 8 students. Okay, some students make a mistake, say 6. No, it's 8. Okay, it's like it's 2 more, and 2 more. 1, 2, 3, 4, 5, 6, 7, 8 students. Super good. So you understand a little bit exponential function. In this case, the base of the exponential is 2. Si you suppose que es 3, entonces 3 students, es 3, es 9, es 27, ¿no? Suppose que in 1 month, whole the college is infected. In 1 month. It doesn't matter how many students. This is no important information. Some people ask, well, professor, I need to know how many students. No. It doesn't matter, regardless how many students. I don't care. It's a super big college. The question is, at what time, how many days, 50% of the student in the college is infected. So in other words, I need to understand, because it's important information, because 50 is a half. Suppose in blue color, I have the student que is no infected, so it's health. And the black guy is the student que have infected. Entonces, in this moment, it's a super important moment to apply the vaccine. See, in this moment, the vaccine is coming, I apply to all the students and the student be safe. Otherwise, no vaccine. Therefore, everyone is infected in 1 month. And my question is, at what day, at what time, how many days 50% is infected? Come on, this is the question. Do you understand the problem? Yes or no? No? No clear? 7 days. Okay, Jonathan Alvarez. Jonathan, wrong. W, wrong. Olga is it? Do you need to know? No, Olga, you don't need to know. Andreina, say 15 days. Wrong, Andreina. Jordan, say 31 days. No. 1 month. Good question. Good question, Jordan. I suppose que 1 month, I put intentionally to confuse you. I suppose que it's a regular month, 30 days. Good question. 24. Rosalinda, say 24 days. Wrong. Launa, say 18 days. Wrong. No extra credit for you. No. No. 30. No, 30 is 100%. Flora say 30. Flora, 10 days. Carlos say 10 days. Carlos Florentino, 10 days. Wrong. Wow, what the hell is that? Okay, 50%. 50%. O sea, in 30 days, 100%. I need to know 5 days. Olga Amaya. Olga say 5 days. Olga say 5 days. Wrong. Andreina, again, Andreina. Wow, Andreina, no. You have no opportunity. Andreina say 14. 14 days. Wrong again. Cesar Dominguez. Repeat again, Cesar. How many days you say? I don't pay attention when you talk about 9. Wrong. Wrong. Everyone is wrong in this class. No extra credit for you. Wow, why not? 12. Danisha. Danisha Prince. Danisha say 12. Wrong. 6. Wrong. Olga. How many times? Olga is 5. Wrong. And Olga is 6. Wrong. 2 wrong, Olga. No, you out the game. Out the game. Another participation. Come on. 11, Santiago Cuartas. Santiago 11. Let me see, Santiago. Santiago is 11. Wrong. No 11. What I understand it's very, very confusing because exponential behave completely different to the common sense. 25. Lorenzo. Alexandro Lorenzo. 25. Lorenzo. 25. Wrong. Wow. Flora. 20. 20, Flora. Wrong. Pero Flora, you participate 2 times. You're out of the game. No Flora anymore. Okay. Entonces, no extra credit for nobody get the extra credit in this class. Unbelievable. You are a smart guy. Okay, I want to prove using the common sense. 0. Santiago is a 0. No, 0, no. Look, 0 was 1 student, in fact. Look, at t equals 0. Oh, yeah, what the hell? At t equals 0, we have 1 student. Student is 1 day. No, 1 day you have 2 students. Look, this is the beginning of the problem. At t equal 1, at t equals 0, sorry, we have 1 student. At t equal 1 day, 2 students. At t equal 2 days, 4 students. Okay? Right, but the base is 2. In this case, I suppose that the base is 2. I suppose that in this case, the base is 2. Si you suppose that the base is not 2, it's 3, it's another problem. No, we can't suppose any base. Suppose base 3. And normally I hear 16. Rosalinda again. Rosalinda say que 16. Rosalinda 16. Wrong again. Jordan, where is you? Okay. Rosalind, Jordan, come on, try. You try. No? Come on, you are a student. You make a mistake, no problem. No. Okay. I respect. Okay. So nobody get the extra credit. Nobody. Yeah, you try or no? Nobody get the extra credit for you. It's a shame. It's 10 points in the test 4. Get the hardest test. Okay, no problem. I explain now. I explain, guy, using common sense first and using mathematics after. The answer is boom. Well, let me explain something. You understand every days, the amount of the student infected is duplicated. Yes or no? 1, 2, 4, 8. At t equal 4 days would be 16, 32, 64, 128. Duplicate. Multiply by 2. And the answer, the question is a little bit confusing because behind this idea, 50%, 50. What means 50%? What means 50%? 50% is 1/2. Let me reformulate the question. See, 100 corresponded with the 30 days, 50% corresponded with the what day? How many days? Do you see more clear now? Every day can increase in 1, 2, 3 days, duplicate the amount of the infected students. Si ahí say que en 30 days or 1 month, it's 100%, and I ask you at what day is 50, tell me please what number of days occur this amount, 50%. The answer is 29. Make sense or no? Make sense or no? It's confusing, eh? Yeah! Rosalinda said, of course, Professor, I understand. Because in 29, I have 50, que is a half of the 100. Okay. For the student that don't understand very well, no problem, I understand. You see, what is the formula? The formula is exponential. The exponential is, look, the base is 2. Entonces, 2 to the 0 power is 1. Yes or no? Any number or quantity or variable raised to the 0 power by definition is 1. 2 to the 1 power is 2. 2 to the second power is 4. 2 to the third power is 8. This is the formula. The formula is 2 to the x power. In 1 month, we have 2 to the 30. This is a huge number. It's impossible to be a student in college. It's because it's a trillion of students. But it's hypothetical. If you divide it by 2, because my problem was 50%, and 50% is 1/2. When you divide the same base, you subtract the exponent, and the exponent is 1. Entonces, es 2 to the 30 minus 1, que es 2 to the 29, que 29 represents the amount of days in which we have 50% of the population. More clear now? More clear now? More clear now? More clear now? Okay. Okay, but I have extra. I have extra question. Maybe out the competition. Well, no. The student can get the idea of this extra, because you understand a little bit now exponential function. You see it increasing too fast. Okay. Some students get there to explain me what happened in 31 days. The coronavirus continue increasing the population of the students sick. What happened with the 31 days? What's going on? And 30 days was one college. One college was 100%, the entire college, no? In 31 days, what happened in 31 days? What's going on? 1 day after the 1 month. 2 college, very well. 2 college can represent 200%. What about 32 days? What about 32 days? 3 college, no, 3 college. No 3 college. No 3 college. 4 college. Okay? And what about 33 days? 8 college. Very well. Duplicate. 1 college, 2 college, 4 college, and 33 days. Wow. In 30 days. In 8 college. In 34 days, and so on. No? Suppose 35 days is 16 college. Do you understand now how fast increasing the exponential function. Here, I suppose hypothetically que the base is 2. Suppose que the base is 3. Wow, increasing too fast. And CF4, more fast. CF5, more fast. Okay? Super. Okay, good, guys. Don't worry for the extra point because you are good student, no? If this is tricky, it's confusing. Yeah, we need the bassinet. Definitely, you need the bassinet as soon as possible. Okay, guys, let me try now so you will have some roughly idea how look like the exponential function. Let me study in detail one example. Example 1. In the test number 4, the first example, the first question, sorry, is do the graph of this exponential function. Bueno, no. In the test, maybe I change. No, do 3 or 5 or 8, okay? Any exponential. But don't worry, I want to explain specific for 2, and after I generalize for any base. Huh? Okay. So I propose you to study this, do the chart like that. In which you put the independent variable, because in this case, the day, 0 day, 1 day, 2 day, and the y value is the exponential, no? And the order pair x comma y to do the graph. Here está en 0. Y is equal to do the 0 power, que es 1. At the point, 0, 1. Wow. And this is the universal point. What is the reason it's called a universal? Universal because any function, any exponential function, sorry, regardless the base, I don't care if the base is 2 or 3 or 4. Suppose I know that the base is 3, but 3 to the 0, 1. And 4 to the 0, 1. And 5 to the 0, 1. And 2 to the 0, of course, 1. And this famous point is the point 0, 1. So when the x is 0 and the y is 1, is universal. Any family of the exponential function passing through the point 0, 1. Always. Suppose 1, 2, 3, 4, 5. So says y equal to the 1, que es 2. The point is 1, 2. Nice. And 2 is y equal to the second power, que es 4. And the point is 2, 4. And so on. Si es 3, it's 8. 3, 8, and so on. Well, 3. Let me do one more. Y is equal to the 3 power. It's 8. The point is 3, 8. Wait. But that's it? No, because theoretically, we include, in the physical problem of the coronavirus, no? But in general, the domain is all real number. That the domain, by the way, I introduced one idea. Domain, the exponential function is all real number because we have no restriction. We have no division by 0. We have no square root. So you can suppose positive and negative, no? Suppose -1. Entonces y equal to the -1 exponent. And you know that when the exponent is negative, es reciprocal, 1/2. Entonces the point 1, -1, comma half. Look, -1 is x value, positive half is the y value. And -2 is y equal to the -2 is 1 over 2 to the second power. Yeah, I know that 2 to the second power is 4. Actually is -2, comma 1/4, 1 over 4. And -3 is y equal to the -3 is 1 over 2 to the third power. I know that 2 to the third power is 8. The point is -3, 1. Okay. So I have some idea how look like that the exponential function, but no, wait. Let's do in the graph in Desmos. It's more elegant to understand this. Okay? Don't worry, be happy. I open Desmos. Boom. I switch in the screen. Share screen with the Desmos. Okay. Yeah, one script of Desmos, but totally blank. Okay, I want to explain. I want to call example 1. Example 1 is the function. Look, it's a function. Okay, I want to call y equal 2. Let me use on the keyboard for the decimal. 2 power exponential x. Wow. Okay, but I need to study a different point. Look at that. The classical universal point is 0,1. Boom. Green color. Every function, regardless of the base, passing through that. Another point specific in this example, the base x2 is 1,2. 1,2. Boom. Look at that, 1,2. Another point in the positive part is 2,4, no? 2,4. This so far look like similar a little bit to the parabola, but no, increasing faster. Look at that. Now it's 3,8. 3,8. 3,8. Okay, 3,8. Look, it's too far. And what are the next? Following the same sequence, 4, something. 4, what? Comma what? 4, what?
You didn't do
16. Very well. You understand now exponential. And 16 is, look at that, increasing factor. This is in the positive part. Let's do it now, the collection of the number in the negative part. In the negative part, we have -1, -1 comma something, -1 comma 1/2. Remember, 1/2. Okay, in this case, for the negative part, I'm using blue color. Look at that. 1/2. 0.5. 0.5. Okay. Now, what happened with the -2? Bueno, -2 is -2. -2 comma 1/4, no? 1/4. Okay, it's on the graph. Look, decimal is 0.25. -3. -3 is comma separated by comma. -3. -3 comma 1/8, no? 1/8. 1/8 is in decimal 0.125, no? One more and that's it. Too much. Separated by comma, -4, comma 1/16. 1/16, I suppose, no? 1/16. Is in decimal approximately, the round 3 decimal place 0.063. Okay. So you see in the negative part it's very, very interesting. Well, the positive part increasing forever. Wow, too fast. Like a coronavirus. But in the negative part, no. In the negative part it's increasing, but it's too slow, the increasing, because remember, increasing is when you're walking from left to right. No, it's not decreasing because you're never walking from right to left. No, this is completely wrong direction, no? Therefore, I can see that the number of the y value of the function decreasing, but never touch the x-axis. Therefore, any exponential function have one horizontal asymptote at, wait a second, let me try. Here, press enter. We have a horizontal asymptote at y0. Because the end behavior of the exponential function approach it, but never touch the x. Therefore, I do the graph, draw like a dotted line, black color. No, this is the important, super important property for the exponential function. Okay. Do you see the idea? Or not clear, confusing? Okay, wait. This is the first example. I promise you we see more. And we have another version of the exponential, more complicated. No, this is the basic and negative exponential function. Now, let me summarize in one piece of paper in the whiteboard the most important property for this exponential function we study right now, no? Is okay, whiteboard, okay, whiteboard, okay, whiteboard, property of exponential function f of x equal, in this case, 2x. Or in general, not necessarily 2, is when the f of x is equal a to the x and a is greater than 1. This property I listed now, 1, 2, 3, 4, 5, is valid or when the base is 2, 3, 4, 3.5, is when it's greater than 1. When it's less than 1, it's a little bit different. Okay, the first property, the most important, is domain. Domain is all real number always in the exponential function. Keep in mind, exponential function is nice function, no restrictions, all real number domain. However, the range, no. Because remember, the range is the y, is the set of the y value. This is the set of x value, no? X value. And x value have no restriction. It's all real number. However, the set of y value, I saw something rule. Do you see in the graphic what is the range or no? No? Not clear for you? Let me come back to the decimal to see the graph again, or no? Okay, the graph look like that. Look, let me do roughly sketch like that. Let me use in green color, something like that. And this is the famous point, 0.1. And remember, the domain is the projection onto the x-axis or real number, no problem, because this is extending in both directions, positive infinity, negative infinity. However, the range, no, because the range is a y value. I can see the y value of the projection is also the positive value. We have no exponential and the negative value. So this 2 to the x never is negative value. It's impossible. When you plug in any number here, never you get negative solution. Entonces, from 0 to infinity positive. No include 0 because in 0 we have the asymptote. And the asymptote, remember, is the imaginary line que the curve approaches but never touch. Therefore, the range is 0.5. Keep in mind, guys, it's important information that we need after that. And this function is also increasing. Remember, increasing is easy because this is the roller coaster car. It travels from left to right, and the roller coaster car goes up always because it's increasing function. And one more important is symmetry. Symmetry is, remember, the category of the symmetry is even, it's odd, or it's neither. What do you think about this? It's even, it's odd, or neither. Remember, even is when it's symmetric with respect to the y-axis, what the classical parabola. Bang is even. Odd is the symmetric with respect to the origin, like that. And neither is no even nor odd. Entonces es obvio que es neither. Es neither because the positive part and the negative part is completely different. Completely different. Anyway. What about one more property important? Well. Number 5 property is about the horizontal. This is important. Horizontal asymptote at y0. Okay, this gets the basic without transformation. And si we have transformation, maybe change. But this is the base. The base exponential. Okay, now, one more important is, okay, one more important is the y-intercept. Well, y-intercept is the famous point, 0,1. And x-intercept, we have no. Look, never. The curve never crosses or touch the x-axis. And the typical point, this is number 7 property, and that, the last one. The last one. The last one. Number 7 property. It's typical point. Typical point. Okay, I strongly recommend to do the graph of the any exponential, regardless if the base is 2, 3, 4, 5, 100. Is you plot the universal point. And you plot, for example, the point is 1, in this case 2, we go 2 to the 1, is 2, no? And another point is -1. If one is -1, 2 to the -1 is 1/2. Is 1/2. And in general, you plot 3 points, que es 0,1 universal, 1,8, for the arbitrary base, que I call A. Suppose que hay another example, que the base is 5 to the x. Entonces, 1 point you plot 0,1, 1,5, and -1, 1 over 8. And when the base is 5, is -1, 1/5. And you are doing the graph of the any. Entonces, you have no problem. Because the question number 1 and the test number 4 is do the graph of the exponential function. You put it the elegant rectangular coordinate system. Okay, no. So I put f of x, suppose hypothetical. I have no idea. Suppose que es 5 to the x. Well, okay, professor. I'm doing my hand. Look, I plot the universal point, que es this, 0,1.
Professor,
Please.
are you still on decimal?
No, sure. I know switching to the whiteboard.
I don't see no whiteboard.
Okay. Let me try to see. Boom. Whiteboard. Switching window. Boom. Do you see whiteboard?
No.
No. Flora is a yes. Entonces, you need to do something in your computer. Carlos.
I'm on my phone.
And it's no blackboard, it's whiteboard. It's okay, whiteboard. Okay, everyone saw the whiteboard. I say restart Skype. It will fix it. Sometimes happen, guys. Okay, you restart. How you restart? You close and open again. Carlos.
Professor,
Please.
I see it now, but can you scroll up so I can take a picture?
Of course.
Professor, do you have time for a quick question?
Yeah. Well, let take a picture and after any question. But let me finish, Jordan. Take a picture, the property. The most important thing is the property. It's a property. You took a picture?
Yes.
Okay. Now, let me finish, Jordan, the idea for the graphic. Suppose in the test, I ask you do the graph of this exponential function. Okay, easy. You can do that in this several ways, but what is the super easy elementary way? You plot the universal point, and you plot in 1 and -1. I know que en 1 es 5, 2, 3, 4, 5. This is the point. 1,5 is point. Y en -1 es 1/5. Entonces, 1/5, using my imagination, is 1, 2, 3, 4, 5 here. I suppose que here. This point is a point. negative 1,1/5. And the graph look like that. Look. I suppose here. And don't forget to draw the horizontal. Wait a second. The horizontal asymptote. This is extremely important. The horizontal asymptote like that. Okay, always, no secret, is a y equals 0. That's it. This is the question 1 in the test 4. Jordan, your question now.
Yes.
Go ahead.
They have these questions starting out in the homework, but it wants you to plot more than 3 points. If we're dealing with the base of, say, 5, no matter what we were doing before, 1/2, 1/4, 1/8, 1/16, 1/32. What is it the same? I'm sorry, I'm not getting it. If the base is 5, what comes after 1/5? Is it 1/10?
Okay, and the hypothetical question, you are doing the homework, no?
Yes, sir.
Already.
Okay. Just saying that
what is the base? What is the base in your example?
Let's just use 5. So here
I have 5 again. Okay, but they ask you another value, okay, no 1, no 0, and -1, another arbitrary value.
Yes, sir.
Well, okay, so definitely you need to use a calculator. Suppose que you want to evaluate in 1/2, it's not impossible. Well, it's possible because it's radical 5. Pero es the decimal approximation you put in the calculator. Therefore, I take advantage 1, -1, and 0 because we don't need to use the calculator. No, don't need calculator. Okay? Otherwise, calculator. Jordan, remember, send me any problem you have in the homework. We try to discuss it after the class. Okay?
Yes, sir. Thank you, sir.
No problem. Entonces, you are ready, no? It's easy for you. Do any graph of the exponential function. Oh, be careful, because we studied so far when the base is greater than 1. And what happens when the base is less than 1? Suppose 1/2. Suppose, okay. I know very well. The professor explained me, I understand. Suppose example 2. The professor explained me 2 to the x. I understand. Okay. However, the professor don't explain me, suppose 1/2 raised to the x. This is when the base, remember, is in between 0 and 1. Remember the base, this is already a number line. Infinity, negative infinity, 0, 1. The base, is, we have 2 possibilities, greater than 1 in that direction, 2, 3, 5, no 1, no, in between 0 and 1 is okay. A negative base, impossible. This is completely out, and 0 and 1 is completely out. So we are talking about now 1/2. 1/2 is here. 1/2. Now the base is 1/2. What's going on? What happened? It's confusing. No. It's similar. Look. Let me explain. We can do similar using the table. We can, of course. Or we're using this resource. Look at that. Take a look now. Important. Extremely important. I know. A 1/2 is equivalent to, say, 2 to the -1. Yes or no? I replace 2 to the -1, raised to the x. And now we're using the rule of the exponent. The exponent in different level is multiplication. It's 2 to the -x. Wow. And you compare this idea and this idea. I know very well. I know very well this graph, but I don't know this graph. But using transformation, I know that when you replace x for negative x, we are doing reflection. Reflection about y-axis. Entonces, to get one roughly idea, look, roughly idea by hand. If we study in the first example, the exponential function y equal 2 to the x look like that. Okay, this is y equal 2 to the x. I suppose that y equal 2 to the minus x, que es equivalent 1/2 raised to the x. Look like that. A symmetric reflection. We are doing reflection about the y-axis. Like that. Okay? That is a reason that if this exponential is increasing, look at the car of the roller coaster goes up. The car of the roller coaster, in this case, is going down, is decreasing. The property is the same, except when the base is less than 1, or in between 0 and 1, is decreasing exponential. Okay, but no, don't worry. This is the rough idea I want to study now in details. Detail, super detail. I go to decimals, I do the graph of the new one using the base 1/2. But it's similar when it's 1/3, 1/5, it's less than 1. I go to decimals. Okay. Let me know when you are switching to decimal, guys. Switching decimals. Do you see decimal now?
Yes.
Yes. Bueno. Entonces I want to call example. Well, let me contraction this. I create a new folder. It's example 2. And this example 2 is y equal, open the parentheses. Inside the parentheses, I put the base, que es 1/2. No 11. 1/2. 1 divided by 2. No double divided by 2. And raised to the x power, no? Exponent x. Boom. Look at the red color. In the red color, the thing that we are doing is a reflection. Reflection about the y-axis. And the point is similar. Let me show you. We have the fantastic universal point is 0,1. So any exponential function passing through this famous point is the same. But you have, for example, the point is 1. 1 is 1 comma the base, but in this case the base is 1/2, not 2. So it's 1/2. Look at that, 1/2. And in this case, let me change the color. Let me change the color to black color. Let me see, black color. So the black color is the point for the decay exponential. Comma. 2 is comma 1/4. 1. And 3 is comma 3 is comma 1/8. Okay, good. This is a decreasing. Okay. Likewise, the correlation of the negative value. The correlation of the negative value is suppose -1. -1, but wait, when you raise 1/2, que es the base, raise to the -1, es recíproca. Entonces you flip it 1/2, entonces 2. Boom. Let me use in the same color, black color. Wait a second. Black color for the decay, black color. Likewise, comma, -2, comma exponent, entonces es 1/2 raised to the -2, flip it, negative exponent means reciprocal, raised as a 1/4, no? It is, no, sorry, F4, F4, F4. Look, this is completely reflection, look, reflection, reflection, reflection. What about -3? -3 is 8. Boom. Okay, put the label of the identification, the point. Look at that, look at that. Okay, let me delete temporary the blue. Okay, I'll keep only the exponential. Okay, one more time happen, exactly the same happen. We have the horizontal asymptote, no? At y0. This is classical. Horizontal asymptote, any asymptote you put in black color dotted line. Bam! And this is the fantastic graph of the exponential function y equal 1/2 raised to the x power. It's clear or confusing? Very confusing or very clear? Okay, let me go. Suppose que in the test, clear, super, Jordan. Suppose in the test number 4, I ask you, boom, canvas, clear. I ask you, do the graph of this. Y equal 1/3 raised to the x power.
Professor, you're still missing.
Sorry, carajo. Always I forgot. Thank you, you remind me. Now, yes? Suppose in the test, or suppose I am bad guy, in the test I write in this way, 3 to the negative x. This and this, you understand, are equivalent, yes or no? Because 3 to the negative x in my mind is -1 raised to the x, and 3 to the -1 is 1/3. Yes or no? So you realize, wow, the base is less than 1. It says in between this interval. Now I know that this is exponential decay. It's going down, decreasing. I plot my famous universal point, que es 0,1. Okay, no bad. I plot +1 and -1. So now 3 points is enough to understand the behavior of the exponential. If you want to do more, well, let's do it more. Why not? Because -1, when you raise 1/3 raised to the -1, 1/3 1 es this point, es reciprocal, es 3. Entonces es 2, 3. This is 3. This point is the point, -1, 3. And 1 is 1/3 raised to the 1, or raised to the 1, and 1 is a stupid exponent, it's exactly 1/3. And 1/3 is supposed to here. And this point is the point, 1, 1/3, and my exponential function look like that. Let me show you. Now remember, it's totally asymptotic, never approach it, but never touch, because we have here the horizontal asymptote. At y equals 0. End the story. Okay, so now you need to be ready in the test 4, because the question number 1 is do the graph of the exponential. Guys, I don't know. I put like that, 2 to the x. I put like that, 4 to the x. I put like that, 1/2 to the x. Or like that, 1/4 to the x. Or like that, 3 to the -x, or 5 to the -. You need to understand that this is increasing, decreasing, decreasing and decreasing because I use a negative exponent. Okay? Clear? No problema. Okay, 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 no bad. And the rest of the time that we have, let's try to understand the exponential equation. Exponential equation, guys. Okay, this is the confusing, very, very confusing. Exponential equation. Exponential equation. This equation, how you identify que es exponential equation? Well, you identify because the unknown in the exponent. Suppose one example. Example number one of the exponential. Suppose 2 to the x equals 4. Be careful. It's not 2x equals 4. This is not exponential. This is a linear equation. And you divide it by 2 both sides. X equal to. No. No. This is intermediate algebra. It's called algebra, exponential equation. You need to find the exponent. It's obvious using the common sense that the answer is the same. It's 2. Because 2 to the second power is 4. But what is the procedure? The formal way to solve this? Say again?
You take the square root. You square root both sides?
No, it's square root. The exponent is x. You take, in this case, you take x root both sides. No square root. No. Listen to me. This is a new idea. New idea you never see before. Okay, okay. This is very, very complicated. But today, no. Today is easy. It's the easy exponential. We have easy exponential today and hard exponential tomorrow. Tomorrow, no. Next week. The easy exponential is the exponential equation, in which you can manipulate both sides in order to express it in the same base. Look at that. 2 to the x stay the same. Well, I know that 4 is 2 to the second power. Yes or no? Now, if this exponential is the same equal sign, it's because the exponent is the same, x equal to. When the base is the same. When the base is not the same, no. And this is the formal way to solve this. The reason behind this is because the exponential function is a one-to-one function. Yes or no? Remember the idea that we discussed in last class? Exponential look like that. When you apply the horizontal line test, pass the test. Pass the horizontal line test. So therefore, I forgot to say that the exponential function is one-to-one function. Therefore, we can apply this idea. Some students and even tutor doing in that way 2 to the x is equal 2 to the second power and cancel out these two. And this is true, but it's not good. It's not the strictly formal way to solve that. Personally, I don't like this way. Remember, I am mathematician. I am picky, in this idea. Cancel out, no. You say you write like that. If 2 to the x is equal to the second power, because this is exponential, and the base is the same, then the conclusion is x equal to, because the exponent should be the same when the base is the same. Okay, let's practice this equation. This is the straightforward elementary example, but I want to complicate your life now in the 10 minutes that we have. Look, example 2. Suppose this equation, 2, 3 minus x equal 8. Solve for x. Entonces, the first thing you should do is try to see si es possible or no, manipulate both sides in order to express it using common base. ¿Es possible or no? ¿Es possible or no? Manipulate both sides. Yeah, how, Olga? Help me.
If x was 1,
Is what?
to manipulate it, you said to make the base so that the exponent is 2, if it's 3 minus x, if x was 1, we make the base, we make the exponent 2.
This is what is your answer?
So I would say the value of x 1.
No, 1. Look. Okay, you manipulate the right-hand side. Look, you manipulate the right-hand side. In this case, not necessarily always the right-hand side. But in this case, you manipulate the right-hand side because I realize exactly, Jordan. Because I know that A is 2 to the third power. Therefore, I manipulate both sides in order to express it both sides using the same base. In this case, 2. Not always a 2. And now I can put the exponent like the same. So 3 minus x is equal to 3. And you magically, it's magic. This is magic. You convert exponential equation to linear equation. Using this magic idea, magic, guys, it's magic. You convert exponential equation from exponential to linear equation. And entonces es obvio que es 0, ¿no? Let me move x to the other side. 3 minus 3 is equal x. 0 equal x. X equals 0. Okay. Let's continue working in this. This is nice. I like that. I promise in the test 2 examples of this, in which you, in order to solve in the linear equation, the exponential equation, sorry, coño, you can manipulate both sides in order to express it using the common base. Suppose this equation, I put it in the test. 5 raised to the 2x plus 1 equal 25. What should I do? What should I do? We can manipulate both sides in order to express the common base. And what is the common base in this case? Huh? What is the common base? Come on, guys. How you express both sides using the common base? And what is the common base?
The base 5?
5. Because I copy 5 raised to the 2x plus 1 equal, 5 is the common base. 5 to the second power, no?
Yes.
Then, if this exponential is the same, and the base is the same because I create this idea, 2x plus 1 is equal to. You take only the exponent part, this should be equal to. And you solve this linear equation, piece okay. 2x is equal to minus 1, get 1, divided by 2. X equal 1. The answer is 1. End the story. Wow, what the hell is that? 1/2. And you need to verification here? No, you don't. But okay, just in case if you want. So the exponential equations are super nice. As you are doing well, you don't need to check it. No mandatory check. You want to verification that you are doing right, you can, of course. But the exponential function never mandatory verify. The logarithmic we study next class, yes, it's horrible. You need to verify, mandatory verify. Suppose example 3. 27 raised to the 4x equal 9 raised to the x plus 2. Okay, my question is, what is the common base? What is the common base? 3, very well. Jordan said that the common base is 3. So you need to express, in this case, both sides using common base 3. To say 27, I know that 27 is 3 to the third power raised to the 4x. Because in one corner of the paper, I put 27, I know, is 3 to the third power. And 9, I know, is 3 to the second power. So it's equal 3 to the second power raised to the x plus 2. Okay, nice. And you apply the property of the multiplication of the exponent when you have different level of the exponent. Suppose you have something A raised to the b is x8 times b. Entonces, 3, 12x. Where come from 12? 3 times 4, x. Is equal 3, and multiplication 2 times x plus 2. Something like that. Now, if the exponential is the same, and the base is the same, then the conclusion is 12x is equal to parenthesis x plus 2. This is magic, guys. You convert magically the exponential function to linear function. Okay, now the rest is piece of cake for us. 12x is equal, apply distributive property, 2x plus 4. 12x minus 2x equal 4. This is 10x equal 4. Divided by 10 both sides. X equal 4 over 10 is 2/5 and fraction. And decimal is 0.4. Either way. Any question? Okay. Let me erase the board because it's, when I write a lot of information on the board is slow. Okay, now it's not slow. Okay, suppose example 4. Example 4. Suppose square root 3 raised to the x plus 4 is equal 3 to the x. Okay, again, repeat the question. What is the common base? What is the common base? Common base. Common base. Common base. What is the common base in this case? 3 again. But I know that 3 is 3. 3 is 3 to the 1. But radical 3 is 3 to the 1/2. Yes or no? Fraction exponent. You replace 3 to the 1/2 raised to the x plus 4 is equal 3 to the x. Now multiplication of the exponent. Entonces 3 to the 1/2 times x plus 4 is equal 3 to the x. If we have two exponential and the base is the same, because I create artificially this idea, magically, the exponent is the same. I see the exponent is the same, so I write my linear equation like that. 1/2 parenthesis x plus 4 equal 1. Equal 1, no, equal x. Equal x. Oh, no, 1x. Okay. Therefore, if you don't feel comfortable with the fraction, multiply the entire equation by 2. You multiply by 2 here and 2 here. This is 1, this is x plus 4 is equal to x. This is 4 is equal to x minus x. I move x to the right hand side like a minus. We combine like that, 2 minus 1 is 1, and the answer is 4. Very well. Easy. I love you. This is the exponential equation because it's easy to solve. Okay, let's do 2 more. In my opinion, it's important, 2 more. 5 and 6. We continue working exponential in the next class. Suppose example 5. Suppose, why not, example 6. Example 5 is 2, 1 minus 2x equal 8 x plus 1. And number 6 is a little bit confusing. It's 2/3 raised to the x power is equal 9 over 4. Which I don't like this. Okay, what is the common base in the first one? What is? What is? 2, very well. This 2, 1 minus 2x is equal to the third power, que es 8, equivalent to 8, raised to the x plus 1. And you apply the rule of the exponent, no? Entonces, 2, 3 times x plus 1. Okay, I put the parenthesis because this 3 multiply the whole thing. So in order to indicate this operation, I put the parenthesis, no? You put without parenthesis, it's wrong, because 3 x plus 1, entonces ahí suppose que 3 multiply only x. No, es incorrect. Entonces, if the base is the same in one exponential, the exponent is the same. 1 minus 2x is equal 3 times x plus 1. And you solve in this elementary linear equation. Entonces, distribute the property to remove parenthesis 3x plus 3. I try to combine like term. So 1 stay, minus 3 I move to the left, 3x stay in the right, plus 2x I move to the right, and this is negative 2, and this is 5x. Divided by 5 both sides. The answer is x equal minus 250. And this is the final. Super, eh? Easy. The last one. The last one was confusing. No, it's not confusing. Because I know que 9 is 3 to the second. Go ahead.
Can you
Please.
move this? I can...
Yes, of course. It's okay for you, miss?
Yes, I got it.
Okay, in the last equation, I know que 9 is 3 to the second, and 2 and 4, sorry, is 2 to the second. So I write like that, 2 thirds, right to the x power, I don't touch that part. But this is 9 is 3 to the second, and this is 4 is 2 to the second. Oh, nice. And we can condense it in 3 over 2, right to the second. Something like that. You see the transformation? I just apply rule of the exponent. When you raise to the second power a fraction, you raise the top part and the bottom part. You are doing both directions. Okay, but the base, the base, professor, is not the same because the 2 thirds in the left is 3 half in the right hand side. Why don't you flip it? You flip it. Flip it what? Whatever you want. Suppose I want to stay here, exactly the same. But you flip it this, 2 thirds. And when you flip it, reciprocal is negative point, minus 2. Wow. Now if this is the same thing, it's because x is minus 2. End the story. Final answer. Any question, guys? Okay. So again, we continue. Again, recommendation, try to do your homework. Any question, please don't hesitate to ask me anytime. This weekend, I am available. I don't need to grade any test. I am so proud for the result for the test number 3. You are doing well, very well. I suppose in the test 4, que hard, you are doing also well. And you pass the class. Okay? See you guys. I love you. Okay.